Good day to you, students. Let us continue with the chapter Some Natural Phenomena. I had covered a little part of it, and a little bit is remaining. So, let us continue with that. Okay, so the story of lightning is already explained to you. Uh, so, I was explaining to you about an electroscope. Okay, and I just told you briefly that it is just like a glass container which has a metal rod and with two metal strips. Okay, so here is a representation of that electroscope. First, let us understand why is it used. Electroscope is just used to test, whether an object, whether it is charged or whether it is not charged. Simple. That is the purpose of an electroscope. So, if for an exam you are asked why is electroscope used, you should be able to tell that it is only to test whether an object has charge or it does not have. Okay, now what do we mean by a charged object? We have already discussed this. I'm just trying to recap whatever we have studied. Charged object is nothing but, in general, any object that you take, maybe it's your pen or maybe it's a paper, whatever, okay, is always electrically or neutral, which means the number of positive charges and the number of negative charges are equal. So when I say an object is charged, that means there are unequal number of charges. It can be positive unequal charges or it can be negative charges. So the moment there is an inequality in the charges, then we say that the object is charged. And I gave you an example the other day of your scale, and I said like, okay, it has 10 charges, 10 positive, 10 negative. That means it is electrically neutral. That means it is not charged. The moment I somehow manage to give two more positive charges, then that scale now is positively charged because the number of charges, positive charges are 12 and number of negative charges are 10. Okay, same way, if I manage to remove 10 and 10 charges, again neutral, remove two charges which are positive, then what will happen? It will have 8 positive charges now and 10 negative charges. In this case, this object will become negatively charged. So electroscope is used to check whether such objects are charged or not. Okay, so this is a diagrammatic representation of it, and what it is just a bottle, you can say glass bottle or glass container, which has a copper wire. Now why is copper used? Copper is a very good conductor of electricity. That is the reason even your electric wires, you see them with copper. Okay, technically even gold becomes a very good conductor of electricity, but you know how expensive is gold, so they can't use wires made of gold. Okay, so copper is used. Now copper will charge, you will be used to transfer those charges from where? From the metal foil which you can see on the figure. Okay, metal foil to the copper wire, and it is reaching to the aluminum foil. So the moment the charges are transferred, the end of the aluminum foil has two ends. It's like a Y, right? So the charges will be transferred on both the legs of the strip of the Y. And when that thing happens, both of them are positively charged. And I've already discussed to you with regards to this in the previous video that the moment the charges are positive and positive, they will repel each other, or negative and negative, they will repel. So that's how we can come to know whether an object is charged or not. So let us look at the definition. An electroscope is a device used to test whether an object is having electric charge or not. Okay, and so this is just about, I would say, a kind of a recipe or a method how you can make a electroscope at home. And since now it is locked down and you're most of the time free, having a lot of time, you can try experimenting with this and see how it works. I hope this part of electroscope is very clear. Okay, next we come to learning a subtopic, that is electric discharge. So let us understand the title first. Okay, electric, that means we are talking about some charges, and it is a discharge, which means it is moving out or coming out. Okay, now whenever you have a boil on your hand, okay, and you break that, remove that skin from there, what happens? There is a kind of a fluid that moves out from the boil, right? So that is called that fluid discharge. So when we are saying an electric discharge, we are trying to understand charges are given out from where? From the cloud. So the process of electric discharge can occur between two or more clouds. That means when two clouds come in contact with each other, that means they brush against each other or hit against each other, that's the time electric discharge happens. So what is this electric discharge? Basically it's just a lightning, okay, or between cloud and the earth. Today, we need not get frightened by lightning like how our ancestors did. Now we understand the basic phenomenon. Scientists are trying to hard, to improve this understanding. However, lightning strike could destroy life and property. It is therefore necessary to take measures to protect ourselves. So what is this entire slide trying to tell us? It is trying to tell us that what is the meaning of electric discharge? That means it is just basically, in simple terms, a lightning. Second, it is trying to tell us that our ancestors, that means our great grandparents, they were always scared about this lightning, and they would always feel, that it is God who is punishing. That is how they believed it, because it was like, sound and the light coming from the sky, right? So they would feel that, God is angry, and that's the reason he is punishing. But it's not the case. Now we already know, and even if you do not know, you will understand it now, that a lightning is nothing but an electric discharge. That means two clouds come in contact with each other, a lightning is struck. Okay, so that is the understanding of electric discharge. So what's a lightning conductor then? A lightning conductor is basically a wire with a rod. That's it. Okay, so what are they doing? There's an example over there. They're showing a model of a house, and then a tall rod that is facing straight up in the sky is connected with a wire, and then it goes down. Okay, and those small tiny lines which you can see at the base, okay, like small lines which are in a form of a triangle shaped, okay, though that symbol is nothing but it is called earthing, which I was telling you. When wires are connected and put it deep inside the ground, it will be called as earthing. So that is a symbol for earthing. Okay, now what is happening in a lightning conductor? Lightning usually strikes, a place which is, pointing straight up in the sky. So what are we doing here? We are forcing lightning to strike that tallest metal rod which is there. Okay, instead of hitting the entire house, we are making it to hit, the exact height of that pole. So what will happen if lightning strikes the pole? Lightning is basically electric discharge, that means charges. Now from the understanding of an electroscope, we know that the charges are transferred from one point to another with a metallic source, right? So metallic object that is there. So here the metallic object is nothing but the wire. So once the electric, the charges hit the pole with the wire, they will be connected and straight go into the ground. That is how the lightning conductor protects the house. Otherwise, what would happen if, say for example, the lightning strikes the entire house? Now you know that whenever constructions are done, there are all metal rods that are put inside the wall, and then it is cement, right? So what will happen? This metal rods will be charged, and if any wire which are coming in contact with it, and if your TV is connected probably, then the charges will get transferred from the plug to the TV. And since it is lightning is nothing but charges which are in big quantity, large number, the entire your electrical instruments can get spoiled. So a lightning conductor helps you know to avoid such things. So let us understand it with a definition. So a lightning conductor is a device used to protect buildings from damage due to lightning. So the metallic rod will absorb the entire lightning, and then it will send it straight to the ground, protecting all the appliances and the entire house and people. Because if at all you were leaning on the wall when the lightning strikes the house, you will be the source to conduct those charges, and then you can understand what could happen to you. So a lightning conductor basically protects you or the entire life and property. This is just an example which I've already told you now. So how do we protect ourselves from lightning and thunderstorm? So there are two situations. One, when you are already outdoors. The second, when you are indoors. Okay, the RS is come down there. So there are two things that can happen. So how? This is the simplest solution when you are outdoors. So protection from lightning and thunderstorm. So what are we doing? We're taking a position like this, okay, when you're outdoors. Now, why this position? Why do you have to sit? Is because whenever you are on an open area, whenever you are outside, you become the tallest object in the surrounding as compared to the ground. Okay, so what will happen? The lightning will come closer to you, it will strike you, and then the charges will get transferred, in the process killing you. So whenever you bend down, you are getting lower to the ground, which will force or channelize the entire lightning charges to hit something that is around you, which is much more taller than you now. So that is how you can protect yourself from lightning when you are outdoors. Okay, whenever one second. Okay, so whenever you are indoors, then how you can protect yourself? Avoid touching or staying close to the walls. Dismantle all your electrical appliances from the socket board. Okay, and sometimes don't use telephones which are connected wired. You can use a cell phone but not a wired phone. You should not use it when it is charging. Okay, so these are some of the things to help protect yourself from lightning. Avoid being in an area with which is surrounded more by metal. Okay, sometimes some houses, the entire roof is a certain part of the house is a shed which is of metal. So avoid staying in such places. If you are again outdoors and there are a number of trees over there, trees actually become the taller object than you, so avoid staying under the tree also. Okay, so these are some of the ways that you can protect yourself from lightning. I've already explained to you what causes an earthquake. The core being hot, and then it boils, and then it moves those plates, and that's how the disturbance. I give you the example of the container kept on, a flame and then water boiling, the same thing. Okay. Now, seismic zones in India are Kashmir, Himalayas, Indo-Gangetic Plains, northeastern region, Kutch, Rajasthan, Andaman and Nicobar Islands from regions of South India. So what are these? These are nothing but those places where the the plates actually meet each other, so there is a kind of a thin imagine that thermocol example, when two thermocols are kept close to each other. Okay, so that which we are talking about, the space, right, will be a kind of a seismic zone. So is Goa coming under this region? No, it does not. Okay, so that is how whenever an earthquake even strikes, you can feel that there was an earthquake, but it is not that the impact is not felt in Goa, because Goa doesn't come under the seismic zones. It is these places: Kashmir, Himalayas, Indo-Gangetic Plains, northeastern region of Kutch, Rajasthan. That's why in Gujarat, when there was an earthquake, Kutch is in Gujarat. So that was terrible in that place. Okay, a slight movement of those plates destroyed large number of life and property. So the power of an earthquake is measured on a scale called Richter scale. Okay, it's not Richter scale. Okay, it is a Richter scale. The T is silent over there. Very destructive earthquakes have magnitudes of more than 7.5 on a Richter scale. Okay, I will explain how this scale is and so on in maybe in later part. But a magnitude, like imagine, okay, you are using a ruler to measure some distance. Okay, so centimeters is what you will use. Same way to measure an earthquake intensity, how strong is the earthquake, we use something called as Richter scale. Okay, and any magnitude that is more than 7.5 is dangerous. Okay, and how long is an earthquake? Can you think, just guess, a time? Will it be 1 minute, 2 minute, 3 minute? No, an earthquake strikes, occurs only for few seconds. Okay, like 20 seconds, 30 seconds, but the entire impact that is felt is disastrous. So earthquake produce waves on the surface of the earth called seismic waves. Seismic waves are recorded by an instrument called seismograph. I'll show you the image of a seismograph. So these are the zones which are there. Okay, here on in the second image you can see all these purple colored lines. They are all these plates that are there. Okay, all those plates are joined close to each other. They're not joined as such, but they're close to each other. So the moment that is the core starts boiling and it is moving, it makes these plates, see the entire region, make it move, and that is how an earthquake is felt. So how do we protect ourselves from earthquake is what we are going to study in the next class. I hope the understanding of whatever is being taught today is clear. If not, then please go ahead, watch the video again and make your doubts cleared. If you still have questions, then you can write them down in the comment section, and don't hesitate to ask anything you feel, that the thought that comes to your mind. Till then, take care, be safe, and protect yourself. Not from lightning, from corona.